All right, guys, I'm going to go through my algorithm of how to do this. It's a sliding window, but I wrote it a little bit differently than some other stuff I was looking at. So I'll first explain what's going on. So let's just say we have the code that looks like this. Down. All right, so let's say we have a string that looks like this, right? A, B, C, I don't know, G, B, F, I don't know, R. What we're going to do is the following. We're going to create two trackers. We're going to create a low pointer. We're going to call it low. So if you look up here, low index, it's going to be this, right? And we're also going to have a hash table over here. And the hash map is going to store the key and the val. So the key is going to be the character. So what we're going to do is we're going to say, all right, so this is the low pointer, and the high pointer is going to be here. And you say, all right, well, the current character is A. Okay, you're going to go through here. If store, does this thing contain an A? No, it doesn't contain an A. So let's go ahead and put in. I'll do a different color. Let's go ahead and put in A. So the key is going to be A. Bad color, hard to see. The key is going to be A, and the value is the index. So the value is going to be 0. Okay, and now you look here. What do? We increase the count. So now our count is going to be 1, and our high index is going to go up. So our low index is just going to stay right there. Our high index is going to go up to, we'll do our high index in green. Our high index was here, right? I guess we could sort of do this. So our high index is now going to go to here. So this is 0, 1, 2, 3, 4, 5, 6. Okay, great. We could get rid of this one. We'll go get rid of that. Now the high index is at 1. Is B in our table? Nope. So let's go ahead and put it in. Now the high index is going to move. So let's go ahead and have the high index move. So the high index is going to move. Our count's going to go to 2 now. So now our count is going to go to, so we're right here. Okay. Our count is now 2. So our count isn't 1 anymore, our count is 2. And our high index is going to go to here. Okay. And now we're going to say, is C in here? Nope. And what index is it found? It's found at 2. Okay, so our count's going to go to 3. Because now our substring is ABC, so our substring is 3. Great. All right. Awesome. Let's go ahead and increase our high index again. All right. So G isn't there, so let's go ahead and put it in. And G is at index 3. And our count is now 4. All right. Uh-oh. We reached an index B. Let's look here. It says, if store contains current character, yes, it definitely contains a B. Okay? You're going to remove char at low index. So what we're going to do is we're going to say, well, we're going to get rid of all the characters until we find B. So it's going to just go ahead and we're going to say, get rid of the low index. So the low index is 0 right now, right? 0. So we're going to get rid of the character at 0. So we're going to say, get rid of s.char at low index, right? So s is the string, and the char at low index is 0. So we're going to get rid of, well, if we're looking here, A. So let's go ahead and get rid of this key, A. Goodbye, A. Great. So now we're going to go and we're going to go again. We're going to say count minus minus. So we're going to decrease our count. Oh, by the way, we're checking our max here. This is really important to understand. When we find it, we're going to check our max. We say, okay, max equals, is count greater than max? In this case, our count was 4, right? Yes, it's greater than our max. So our max is now count. So just put max is 4. This is a little weird. We're going to decrease our count. Well, why are we decreasing our count after we remove an item? We're decreasing our count because there's now one less item in our substring. So our count's going to get decreased to 4. 3 rather, because it was 4. And now we're going to move our low index up to here. Right there. It's going to do that. I'm just going to say, all right, let's go back to top. Well, s dot contains key, it contains key current char. Again, the current char was where B. Does it still contain B? Yes. So we want to remove s.char at low index. So our low index now is 1, and we're going to remove B, because if we look at our string, this is our string here, and the char at the low index, 1 rather, is B. So we're going to go ahead and get rid of this. And now we're going to decrease our count to 2. Which makes sense because there's 2 items here. There's 1 and 2. Great. All right, let's go back to the top. Okay, decrease our count. We're going to move our low index up 1, actually. Let's do that first. So we decreased our count. We're going to move our low index up 1. Okay, great. Excellent. So does it now still contain the current char? No, it doesn't contain a B anymore. Remember, the current char was B. It no longer contains a B. We're good. We got rid of it. Great. Fantastic. So let's go ahead and keep it moving now. We're going to put s.char at high index. So where was the high index? We haven't moved it because we got stuck in here. So we're going to go ahead and put in B. So we're going to put in B, and that's at 4. And after we do that, we're going to increase our count to 3. So our count's going to go to 3. So if we look, we have 3. Great. And now we're going to move our high index up 1. Okay, well, our high index was here. And let's go ahead and move it to here. So we're going to say, well, our current char is s.char at high index, 5. Does it contain an F? Nope. We're going to put F, 5. And now our count is going to go to 4. Great. Let's see here. Looks pretty good. And then we're going to go ahead and move it again. It's going to be, does our thing contain an R? No. So we're going to put an R. That's an index 6. Then our count is 5. So we have 1, 2, 3, 4, 5. Great. Awesome. Now we're going to go up here as high index. And then we're here. We're going to do this now. It's going to be, the high index is now 7. Is high index 7? Let me change the color so you can see it. Is 7 less than the length? 7. So is 7 less than 7? Nope. 7 is not less than 7. So we are going to get out of this loop, and we are going to return. The reason why you have to do this, you're going to return count greater than max, else count max. So this would this happens if you have like a space or something, or only one character. So you're going to say, all right, well, either we're going to return, if count is greater than max, we're going to return the count. Otherwise, we're going to return the max. Because sometimes you only have one character, and you'll end up with max at 0 because we didn't have any repeats, and count is 1. So that will take that case into consideration, and then you're done. There's better ways to do this. I use the hash table. There's probably more efficient ways to do this. I don't know. I thought this was pretty easy to do though. Really important part of this is understanding that you have to decrement your count as you're taking items out, and you have to increment your low index so you're moving up. Okay, you move the high index gets moved up in the outer loop, and the low index gets moved up until we find the character that contains it. We just keep popping characters out of there until we get rid of the duplicate, and then we start from there. Basically what it does, it just creates, it's a sliding window. So like creates a window like this that just sort of moves. So like, for example, I found B before. So the original window was, let's see if I could sort of do this. The original window was this. Okay, I found a B. So then the next window became this. So I kept moving. Okay, pop A out, pop B out. I get to C. So the next window is going to look like this. That's the second window. And this window is extending by the high index, and it's decreasing by the low index every time we go in here. And that's what that's doing. And the size is just the count minus minus is just keeping track. We're saying, well, we have to decrease the size by 2, right? Because we're getting rid of some items in the hash table. So that's why it's called, excuse me, that's why it's called the sliding window, because you're making these windows. You're starting out with the black window, then you're decreasing and you're increasing from the blue window. What's neat is you don't have to increase all the way from here. You know you got to here before, right? The high index was here until I found a duplicate. So I could just keep going from here. When I originally wrote this, I kept going from 1 over from the index I found, which made the algorithm pretty slow. So hope you enjoyed this video and you kind of understand what the sliding window is. And it's not really mysterious. It's pretty straightforward.